This video is about getting adjustable gain in an amplifier. It corresponds to section 19.4 of Applied Analog Electronics. Now, the idea of adjustable gain is like the volume control on stereo. You want to be able to control how loud your output is by turning a knob. And the way we do that in an amplifier varies a lot depending on the type of amplifier, and there's lots of different ways to do it. The simplest thing is just to use a voltage divider. Okay, so if we've got something we want to adjust from all the way off, so that's a gain of 0, up to some maximum gain, we can do something where it says, okay, take the input and stick it into a resistor, and now we can put a potentiometer here as the resistor. A potentiometer is just a resistor with a wiper arm that moves from one end to the other and makes a voltage divider out of the resistor. So there's a resistance above the wiper arm and there's a resistance below the wiper arm, and that's a voltage divider. Now, if we're trying to get a gain of 0, we usually are looking at voltages with respect to some reference voltage Vref. And when we want a gain of 0, we want to just have Vref. So let's put Vref at the other end here. Now, when the wiper arm's all the way at the top, we're just connected to Vin. When the wiper arm's all the way at the bottom, we're just connected to Vref. So we have a gain of 1, Vin times 1, or 0. So again, Vin is reference to Vref, just like our output is. There's one little problem with a voltage divider like this, and that is, because this is a voltage divider, we're not allowed to take any current from it if we're going to use the voltage divider equation. If we take current, the computation changes. So why don't we put it into an amplifier? An amplifier that doesn't require any current at its input. If this has got a gain of G, then the gain control here will go from 0, if we're all the way down here at Vref, up to a gain of G when we're all the way at the top. And that's a very nice adjustable gain control. Which way around do we want to put the potentiometer? Now, usually if you look at the volume control on a stereo and you try and turn it, you turn the knob all the way counterclockwise and you get 0. Turn the knob clockwise and it gets louder. So we want the clockwise end of our potentiometer to be at this end, so that when it's clockwise, it's as loud as it can get, and when it's counterclockwise, it's at 0. Okay, that's one way to get adjustable gain. It's just to use a voltage divider and an amplifier. What if we want to save some resistors? You know, this has got some resistors in it. We can put the gain control here inside the amplifier. Let's take a look at a non-inverting amplifier. Okay, so we've got our non-inverting amplifier. It's got a positive input that just comes from Vin. So we're not taking any current here from Vin. Notice that this voltage divider method did take current from Vin. So we probably want this thing to be coming from something that can provide current, like another amplifier. This one, we don't need any current, so this could be coming directly from a sensor or something. So that's one possible reason for choosing this one, is it doesn't require any input current. All right, so what do we do for the feedback? Well, we can take the output here, and we wanted to have a voltage divider to Vref to feed the negative input. So why don't we just make that voltage divider out of a potentiometer? Now what have we got? Well, what's our gain here? Well, if we look at it, we've got RF above the potentiometer arm and RI below that wiper arm of the potentiometer. So the total potentiometer here is RF plus RI. That's a fixed value, but how much of it's RF and how much of it's RI depends on where we've got that knob turned. If we've got the knob all the way to the top, well, what's the gain? The gain is 1 plus RF over RI. So if the knob's all the way at the top, we get a gain of 1. And if the knob's all the way at the bottom, we get 1 plus the total resistance of the potentiometer divided by 0, that's infinity. So this is going to be a 1 to infinity gain. And where's the maximum gain? It's at this end. So we want that to be the clockwise end. Now, we can't really get infinite gain, and we might not want to even attempt to. So let's say we wanted to get some reasonable gain. Like, let's say we wanted to have a gain that ran from 1 to 20. How would we do that? And let's say we had a 10 kilo ohm potentiometer. All right, so we're going to do this design, but we need to change things a little bit so that the Ri never gets that small. All right, so V in is still going to be coming in here. V out is still going to be coming out here. We're going to have that potentiometer with the feedback. But when we're all the way down at the bottom end here, we want to have still some resistance left. So we'll put another resistor in series there. And this was going to be the 10 kilo ohm potentiometer. And this is going to still be the clockwise end. So the question is just, what's this resistance out here? Well, when we're all the way at the bottom, we want to have 1 plus RF over RI as our gain. And that's 20. So we want to have RF over RI be 19. RF will be just the 10 kilo ohms all there. So if we take the 10 kilo ohms and let's see, write down the numbers here. We want 20 equals 1 plus RF over RI. 19 equals RF over RI. RI equals RF over 19. So take that 10 kilo ohms, divide by 19, and we want 526.3. And it's not quite a standard resistance. I think 510 is, though. So let's make this a 510 ohm resistor here. And what's the gain going to be? Max gain is going to be 10 kilo ohms divided by 510, or 19.61 plus 1. So that's going to give us a gain of 1 to 20.6. Okay, that's it for non-inverting amplifiers. Let's look at inverting amplifiers. Can we do a similar thing with the gain control there? Yeah, it's just a little bit different because we've got our amplifier, and now the positive input is going to go to Vref, and the negative one, we still have to have a resistor here, but then we can put the potentiometer here as just a variable resistor. So there's V out coming out, V in coming in. What is the gain of this inverting amplifier? Well, it's just going to be minus RF over RI. And RF here is going to be that part of the potentiometer that isn't short-circuited. So if we're all the way at this end, it's 0. So that's going to go from minus 0. And if we're all the way at this end, it's the full minus RF over RI. So this is our range of gain. Let's say we wanted to get from 0 to minus 20. What would we take? Again, if we use a 10 kilo ohm potentiometer here, then we need Ri to be 120 of that. So again, that's about the 510 ohms. And our gain now goes from 0 to minus 19.6. So it's fairly easy to design a gain control for an inverting amplifier as well as for a non-inverting amplifier. Now, we use inverting amplifiers, or things like inverting amplifiers, for a couple different purposes. In addition to just simple inverting amplifiers, we also use them in our active filter designs. So you can do this sort of gain control in an active filter as long as the resistor that you're adjusting is not being used to set the corner frequency of the filter. because then you'd be changing the corner frequency as well as the gain, and that's not usually what you want to do. We also have a very similar amplifier design, which we haven't talked about yet, just as we haven't talked about active filters, and that is, if we leave out this resistor here, the RI resistor, we have what's called a Trans-Impedance Amplifier. And the gain of a Trans-Impedance Amplifier is just the feedback resistor. So here the gain would be 10 kilo ohms, but we can adjust that from 0 to 10 kilo ohms. So you can make an adjustable gain Trans-Impedance Amplifier also. It's just like doing an adjustable gain inverting amplifier. Okay, I think that's probably enough on adjustable gain.